Thank you. I'm going to present some work that has been done by one of our master's students when I was in Cape Town already a few years back. And he did look at the Siphonophore community along the east coast of the South Africa. And the east coast is actually based by the Agulhas Current. Agulhas Current is one of the biggest, even though the largest, western boundary currents, located in the southwest Indian Ocean. The flows carried by the current is about 70 sverdrup, and much more water transported by that current than any of the other current, and is a key player in the exchange of water and heat and salt between the Indian Ocean and the Atlantic Ocean. It forms south of the Delago Bight, about here, and it flows southwards along the east coast of Africa and closely following the bathymetric slope. It retroflects at the bottom, and actually there's some bubbles of Indian Ocean moving up in the Atlantic Ocean. So the continental shelf is narrow, it goes really deep really quickly, and so the topographic is actually controlling most of the stability of the current. So the current is very, very narrow, and it's very, very dynamic. There's a lot of ADs going down from the Mozambique channel that's actually being seen in the Agulhas Current. So due to those ADs, there's some local upwelling cells that are developing along the shore, depending on the season, and we'll show you that a bit later. So what's global change going to do into that specific region? SST might increase, and mesoscale activity might actually increase, which might increase the width of the current. What's the biodiversity of the Agulhas Current? There's about 100 different habitats, a few examples, and that goes from mangroves to kelp forest in the south. The Transkei, so the shore of the east coast of South Africa, is important as it also carries or show bight that actually important in transport of water. And there's a well-known sardine run that runs from the southeast to the north along that shore every year, and it's a huge economic value for South Africa. There's reef building on the outer part of the current, but overall, do we have enough information on the ecology and to predict the changes in those sensitive ecosystems? In 2014, South Africa put together the Operation Fakisa, and trying to improve, unlock economic potential for the coastal and offshore environment for the country and its citizens. And in that goal, they want to expand the number of MPAs and trying to make it more working MPAs than just paper MPAs. Zooplankton community, actually it's not very well known. There's only a few data available. On copepods, there's a few papers, and most of them are actually looking at the Agulhas Bank, which is on the south part of that coast. A few from Mark Gibbons on euphausids, lobsters, chaetognats, and ichthyoplankton. There's one paper that by Mark looking at ctenophores, but basically there's very limited. There's not much project going and looking at the whole transect of that Agulhas Current. And among those zooplankton, I've been focusing, which I did already when I'm doing my postdoc in the late past of the century. And siphonophores are very good indicators of water mass. And they have been already used as water mass indicators or water mass movement in the past. And it's what we did already with Mark in '91. And the goal was also to see how the population of siphonophores change or not over time. And trying to see how the population diversity is actually in link with nearshore upwelling or the offshore hot waters. So that's what I'm going to show now. So it's based on a high resolution distribution of siphonophores and how to, along the shore and across the shore is actually showing diversity modulation or not. So that's where we did sample in 2017, 2 cruises, one in January, February, and one in July, August, so summer and winter. 38 transects were done, and 6 to 8 stations across the transect were perpendicular to the coast, and the samples were done from the south, from Cape St. Francis to Port Shepstone in the north. And the samples were limited to the 20 meter to the 1,000 meter depth. Macrozooplankton, among other things, were collected using bango nets, 50 microns mesh size, and were preserved with formalin. We did settle biovolume, which is a non-destructive, very quick way of knowing how much plankton were there. And with Dylan, we look at the Siphonophore population, and we did, mostly did, I supervised, he looked at 95 stations in summer, 93 stations in winter. I have to say it's an amazing piece of work. So we did some statistical treatment at the ongoing work, so please, I haven't done everything yet, but mostly. So if we look at the environment, we can see a very wide differences between the summer on the left and the winter on the right in temperature. And we can see those ADs in blue, the cyclonic ADs that will actually bring some cold water to the shore. So it's transport, strong ADs, and the temperature gradient is much warmer in summer than in winter. So the lowest SST was seen onshore. If we look at temperature, the variation is between 10 and 26 degrees, plus 4 degrees in summer, and lower bottom temperature offshore. Salinity, bottom salinity was high, low bottom in winter, and there were several layers of water mass on top of each other. Chlorophyllae, we can see that in link with the upwelling of cold water, there was some increase in chlorophyllae biomass over the region, and reaching about 123 microgram in integrated chlorophyllae. Zooplankton actually in biovolume is showing very different distribution between summer on the top and winter at the bottom. You can't really see it on the scale, but it's about 5 times more in summertime. So the biovolume goes up to almost 400 milliliters per 100 cubic meters. And there's a large contribution of crustacean, as you can see on the pictures. And students looked at ichthyoplankton too, and they were removed from the biovolume. And the diagram here is actually looking at vertical plankton, and we can get basically the same picture. So in terms of Siphonophore, we've got 56 different species, mostly calicophorans, and we observed Physalia, Cordacalma, and Lancia lupi, that were new record for the region, and we got more species in summer than in winter. So, if we look at the community, there's a clear increase in richness between the shore, the 0 to 50 meter depth, and going towards the core of the Agulhas current. And the species we see that are involved mainly in that trend is Mugaea atlantica, is actually driving most of the abundance in the region, but there's other species that are also important. If we look only for the summer season at the distribution of the main species, we can see the different, watch for the different scale bars, and we can see that actually there were some species that were very common but in low abundance, like Lancia subtilis, but others like Eudoxides spiralis was reaching 220 individuals per 100 cubic meters. And we can see that the distribution is more towards the warm water for most of them than towards the shore, like Mugai. So there's a very dichotomic distribution between Mugai on one sense and the other species. So I tried to do some community structure looking at absence and presence of siphonophores. And actually I was a bit surprised to see something so different, surprisingly so different. So on that cluster on the A is only driven by Mugai atlantica abundance. And I tried to superpose that cluster over the map, and it's all those dark dots. And the rest of the population actually grouped together and was following more nicely the main core of the Agulhas current. So that was in summer. If we look in winter, we see basically the same diversification with A again leading by Mugai atlantica and the rest grouped together. If we look at the map, it's a bit less clear how the two clusters are actually distributed. So that's, like I said, it's an ongoing work. I still have to do more statistics and looking at more in-depth information on the physics, the sea surface anomaly and things like that. But what I try to actually do is that ordination of the species presence, absence, and the different environmental parameters. We can see that the group A is actually driven by chlorophyll concentration, which was richer within the upwelling system. And for the summertime and for the wintertime, bottom temperature and oxygen seems to be partly driving the differences. So, like I said, there's a lot more to go into that. So the home take-home message is that it's one of the most exhaustive data set on siphonophore diversity. I check around, I haven't seen something so with so many stations. And the other study that was done in 91 was only 36 stations over 9 transects. We're done at different stations. We're done at different period. Only February was done during the same time than us. And previously we saw 59 species, so about 5-6 species less. Species were found now that were not found before, and vice versa. And on another work I've done in the Mozambique Channel, I only found 36 species. So the diversity and abundance of siphonophores are seasonally variable, linked with the currents on the Transkei Shelf, and there's a strong dominance of the Mugai atlantica in the Agulhas current. And looking at the ectoplankton distribution, actually the region just up north from that high abundance of Mugai has been identified at nursery areas for several small pelagic fish. So is the potential predation by Mugai and other jellies going to affect the fish eggs and larvae in that region? That's something we need to look into. And Algoal Bay, so this southern section, is becoming also a suitable and potential nursery areas for anchovies. And the anchovies seems to be moving up east under the changes we have seen in the region. So siphonophores are good indicators for water mass. High aggregation of siphonophores have been shown during that work that they do occur at small scale, and they can impact strongly the structure and the functioning of the ecosystem. And under that FACISA, Operation FACISA, the management of the southeast coast of South Africa should take into account the Siphonophore community. So that's mostly all I wanted to show today. I just want to, give an appreciation to a friend of mine, to John Wacky. He was one of the persons that helped me at the beginning. I'm a very good friend of his daughter, and he passed away in August. And thanks for Rebecca. And you see I put some babies Velela in my picture. Here we are.